Hello viewers, today digital circuits are used in large number of equipment such as frequency counters, digital multimeters, calculators and computers etc. In these equipment, integrated circuits are used. These integrated circuits are digital circuits in themselves fabricated on a single chip. How does one test a digital circuit? This is done by using a logic board. Do you know what a logic board is? The test board, which provides logical inputs high and low to the digital circuit under test and can test the logical outputs of the test circuit, is called a logic board. Before we test a digital circuit, let us see the various blocks of a logic board and how it is used. The various blocks are power supply, variable logic outputs, fixed logic outputs, state indicators and test sockets, decoder circuit and clock circuit. And now we come to these sections one by one. This is the power supply section. The AC mains 230 volt is fed to it. Its output is 5 volt 750 milliamperes, which is given to all the sections of the logic board. The variable logic output section provides 8 high or low logic inputs to the circuit under test. With the help of toggle switch, the output can be selected to either high or low. The fixed logic output section provides inputs to the test circuit. This input is fixed and cannot be varied. Red sockets provide high output and the black ones low output. This is the block of state indicators and test sockets. It is used for testing the output of test circuits. This is the decoder circuit used for observing the output of the test circuit in decimal form. Clock pulse to the test circuit is provided from the clock circuit of the logic board. Now let us test a digital circuit using the logic board. Here we have a very simple test circuit, an IC. Let us look at its circuit. In the circuit, the IC shown has 4 NAND gates, each having 2 inputs. Pins 1 and 2 are inputs for gate A, pin 3 is the output. Similarly, pins 4 and 5 are the inputs for gate B and pin 6 the output, and so on. Let us work with gate A. For this, we need regulated power supply for the IC and logic inputs for the gate under test. These are supplied by the logic board. Switch on the power. The glowing LEDs indicate that power is available on the board. To supply the power to the test circuit, connect VCC and ground terminals of the logic board to the VCC and ground terminals of the IC. In the figure shown, one of the logic inputs is fixed and connected to high, and the other one is variable and can be set at high or low. So, we have given the power supply and the logic inputs to the circuit under test. Do you know what we should do next? Yes, we have to test the output of the NAND gate. The logic board has 8 test sockets, each of which is connected to LEDs. Connect the output of the NAND gate to any one of the sockets. The glowing LED indicates that the output is high. When the output is low, the LED will not glow. For this circuit, we conclude that when the variable input is at logic low, the output is logic high. There are circuits like digital counters where the decimal equivalent of the binary output of the test circuit is required to be observed. For that, a decoder with 7-segment display is provided on the logic board. 4 outputs of such a test circuit are fed to the 4 test sockets. The LEDs show that the output is 1, 0, 0, 1. Now, when these 4 outputs are connected to decoder circuit, it will show the decimal equivalent of the output of the test circuit, which is equivalent to 9. So, 9 appears on the display. Certain circuits, for example a counter circuit, need an extra input. This input may be a series of square pulses and is called clock input. The logic board has a clock pulse generator. When the clock input as seen on CRO is applied, the counter circuit counts the number of clock pulses. Let us test a decade counter circuit wired on a breadboard. This particular circuit counts from 0 to 9 and again resets to 0 and start counting. Frequency of clock pulse can be varied with the help of potentiometer. And the frequency range of this particular clock circuit is 200 Hz to 20 kHz. To sum up, the testing of a digital circuit requires regulated power supply, variable logic inputs supplied by these sockets and toggle switches, fixed logic inputs supplied by these high and low sockets, state indicators to test the logic level of the test circuit output. The logic board also provides a binary to decoder circuit with a display. The clock circuit provided on the logic board gives us square wave pulses. Now that you have learned to use a logic board, you are ready to take off with digital circuits.